Hey friends, welcome to Civil Ideas. Today in this lecture I'm going to tell you about the basic rules for design of a singly RC beam as per IS 456 2000. So without any further delay, let's get started. So what is effective depth of a beam? The effective depth of a beam is the distance between the centroid of the area of tension reinforcement and the maximum compression fiber, excluding the thickness of the finishing material, not placed monolithically with the member and the thickness of any concrete provided to allow for wear. This will not happen in deep beams. Now, effective depth is equal to the total depth. See, here the D is the total depth minus the effective cover, or we can say the total depth minus clear cover or by diameter. Let us take an example. So, let us D is equal to 400 mm and the clear cover is equal to 30 mm. Now, there are three number of bars. As you can see, this 1, 2 and 3. Let us take the bar diameter is 20 mm. Now the effective depth D will be the 400 minus the 400 minus the clear cover 30 minus dia by 2. So it will be 400 minus 30 minus 10, it will be 360 mm. Here the effective depth will be 360 mm. Now, what is effective span? As per clause 22.2 in IS 456, effective span of a member shall be follows: simply supported beam or slab. The effective span of a member that is not built integrally with its support shall be taken as clear span with its supports taken clear span plus effective depth of beam or slab or center to center supports. That means you have to take clear span plus effective depth of beam or slab here or center to center distance. Now out of these two, whichever will be less will be considered as the effective span. In continuous beam or slab, there are two cases. Case 1, if width of the support is less than 1/12 of the clear span, then the clear span will be effective depth by 2 plus effective depth by 2. Here why effective depth by 2 is both? Because we are considering two sides of the span or center to center distance between support, whichever is the less will be the effective span, effective depth. The case number 2, for the end span with one end fixed, here this portion is fixed and other is continuous or intermediate span, the effective span shall be the clear span between the supports. For end span with other continuous or for intermediate span, the effective span shall be the clear span between the supports plus effective depth by 2 or clear span plus BS by 2. The BS is the width of the column. Now in cantilever, the effective length of a cantilever shall be taken as its length to the face of the support. This is called the face of support. Face of support plus half of the effective depth, half of the effective depth where it forms the end of the continuous beam where the length of the center support shall be taken. Now it says two things, that is you have to take, if a cantilever beam emerges from only a column, then it will be half of the face of the support plus half of the effective depth. Now if it is emerges from a continuous beam, it means that the cantilever beam is emerges from a, this is the image of continuous beam, then the effective depth effective length will be center of the support shall be taken from here, this is the center, this will be the effective length. Now deflection control, as per IS 456 2000 clause 23.2.1, that vertical deflection limits may be generally be assumed to be satisfied provided that the span to depth ratio are not greater than the obtain values. Now, for example, a span is less than 10 meter. The cantilever beam or slab is equal to span by depth is equal to 7. For simply supported beam or slab, span by depth ratio is 20, and for continuous beam or slabs, span by effective span is 26. Now, if the span is greater than 10 meter, we have to consider the cantilever beam or slab. The span by depth is 7 as it is the above. For simply supported beam or slab, the effective the span by depth ratio will be 20 into here 10 by span. We have to multiply. Similarly, in continuous beam or slab, span by effective depth will be 26 into 10 by span. Thank you.